All right, so today we're going to talk about Windows Login Manager, how you set it up, how you use it. This is just a high-level overview to give you an idea what the system is capable of doing. The system for Windows Login Manager is, works in conjunction with our cloud-based or on-prem authentication server. But to configure it, initially you don't necessarily need to have a connection. You can do it independently, but actually to test it, you'll need a connection. In this case, what I've done is I've started Windows Login Manager by clicking, I've installed the product on this machine. This is going to be my test machine. This is where I do all the configuring of how I want the client end of Windows Login Manager to actually work and operate. And I can do things here by making changes to configuration parameter and retesting it till I get it right. At some point after I get it right and I get done testing, I'd be ready to deploy it throughout the entire network using things such as group policy, SECM packet manager. To deploy the system, it's quite simple, just a few components, but we won't talk about that at this moment. We'll just talk about how you actually configure it. So I launched Windows Login Manager. As you can see, an icon on the left-hand side. The system is installed here in a mode for config. I really need to identify the server components. I don't actually need to enter these now. There you can see on the top where you identify your tenant and your API key. This is so that you can have complete control over which workstations will be accessing the system on the server, how they'll be authenticating. In this case, we've got some test ones set up that we'll use. We're using our sandbox authentication server for this demo. So, and we really are identifying the authentication server side of it first. Then we move on to things such as logging. We have different log levels. You can specify, none, or which is normally what you have once everything's rolled out in production. Tracing, info, warning, and errors. Of course, these all put to a log file that can be spooled to your SIEM system as well for every single workstation if you want to capture that information. Or you could turn it on, dynamically on each machine one at a time, or even through group policy. You have to specify some of the parameters of where you want the files to go, what you want the file name to look like, and the extension. This hopefully makes it easier for you to integrate with your other products that are actually doing any kind of log sniffing or log reading. So system supports a variety of different authentication methods. You get to choose which ones you want your users to use. And in this case, you can enter an OTP, just enter a passcode from mobile app or from a token. You can have the system call the user and tell them the passcode, the OTP. You could have the OTP send the passcode to email or send it to SMS. Now, the email option is here um, for legacy purposes. Nobody should really be sending a passcode to somebody's email. It's just a bad practice, but we do have clients that use this, so we need to support this going forward. We also support push authentication, and there's a variety of different methods. You can send push authentication message to our mobile app. You can actually push a call to the phone to ask somebody to enter, to confirm they want to be logged in. You can also send them an SMS asking them to confirm authentication. Um, you can specify that when you logs in, they can get basically an option to use any of these, or you could basically say in the system, you can say, I always want them to use push. I always want them to use OTP. And you would specify those types of things here where it automatically does this. You doesn't do anything. They just enter the username, password, and the system then takes it from there to authenticating and using the method that either they choose or was automatically decided for them. The push app name and push app reason is what the user will see on their phone so that they'll know it's from the right system. It's basically part of the relying party identifiers that will be seen by the user. And you can tailor this to your own needs. We also have support for FIDO2 and phishing resistant MFA. So that's an optional component that you can use if you choose that that's the way you want to go. That's kind of the path that everybody's moving towards now. We also have some other things that come into the miscellaneous category, such as master code override. This is where you could specify either it's in some group level or an individual level, codes that can be used by an administrator to gain access to the person's computer. The actual codes that are kept or assaulted SHA is the way they're actually saved. You could specify a default domain. We infer the domain. The domain can either be saved. And is it saved as part of the Windows login process? You can override it here so it shows up on each user's workstation as something different than what they normally would see based on what the operating system provide. And then we have two other different types of authentication policies. Uh, You can use it where we're going to ask for MFA for anybody who logs in. But we could say, you know what, we're not quite ready for that because we have some people we're onboarding in a large organization. You might onboard people in groups, and we may say, you know what, we only want to authenticate them in SurePass with MFA if they have an account in SurePass. So that's the first option that you see on the drop down here. The third option is that they actually have a SurePassID account defined and they have an enabled token. So this is a great way for rolling out the product in large scale, and basically not having to configure it differently for all the different workstations. The system is smart enough to find out, what the user has for their account, and then take the appropriate action. We also support a proxy, so if you're using us in the cloud per se or in another network, you can specify to automatically use the Windows proxy to actually send the request to the authentication server. You specify the server and the port. We will then use that capability to talk, that mechanism to talk to the actual server. So these are kind of all the knobs that you have to use when you're configuring the system. The idea is you configure this on a machine that probably looks like one for maybe a server machine, one for an end user machine. You play around the settings. You could have them different. I mean, literally every person could have a different, their machine could have a different configuration if you really wanted to do that. But typically you classify different users that'll get different options for logging in, and certainly different things for admins than versus non-admins. And in this machine, we've set it up so that we can play with this, make the changes, and then log in and test each of the different settings. So in this case, if I said wanted to change anything, I would just hit the save button. It will save it in the registry, and then later on we can actually distribute that registry file to somebody for actually configuration. So in this case, we've got entering the passcode, and we are letting them do a variety of different push authentication methods. We're going to prompt to let the user choose which one of these they want to use in this example. So let me go in here and change this now to lock the user. And now I'm going to log in as test user. And I have this in test mode, so I can log in with user name and password, the Windows base credentials. So if I mess something up, I can still get in and make a change. And this is a virtualized system that I have that just is for simulation. So if I say, okay, let's use SurePass, I can put in the user's password. And I have two choices here. I said passcodes are okay, so I could enter an OTP. I also said, besides that, let them use other choices. So I said, let's prompt them for what they would like to do. And here we get given an option of how you want to let the user. So these are all the things that we said the user was allowed to use when we were configuring the system a moment ago. So in this case, what I'll do is I will do a sending push message to my mobile phone. And then the push message will make it to me onto my mobile phone. And now I will approve it. And I get logged back in. So that's how simple it is. If I wanted to log in with a passcode, I could do a lock, and probably usually having your user set up to be able to do a passcode and another method is a good idea, so that they can always, if they're using the mobile app, they always have the ability to log in with OTP, but for convenience, they can use push. So if I go ahead and do my password again, these credentials are authenticated by Active Directory. And for passcode, I will go get one from my phone. And it logs me in again. That is pretty much as simple as it gets for setting up this system and doing some quick testing. Now, once I get this right, my next step would be, say, how I deploy this. And I can deploy this via, as mentioned earlier, SECM or any package manager that you like, or if the group policy, there's only 3 or 4 files that need to be distributed. You can harvest them from this machine, which is your tested environment, and then basically package them up and then send them off to where they need to go to turn on authentication. There's also another way you can run in parallel mode with Windows single factor and SurePassID second MFA. And then as people get familiar with the system, you can then send a group policy request to actually have all the single factor turned off. And so all these things can be completely automated. There is one thing that I did not mention that is really important, is the security policy. So if I'm doing the security for an individual, if everybody's got a workstation in the office, pretty straightforward, everybody's connected. But what if people travel? What do they have a laptop? Maybe they're not. I mean, they're working from home. There's a variety of different ways that could be configured, through VPNs and other mechanisms. But we do give you the ability to actually support offline. So you can say, okay, so if somebody's offline, we could say, okay, you can require offline MFA, which means they'll have to put an OTP code in. We could also say it's not allowed, period, which should be the default. Or we could let it go to username and password only. So if you pick username and password only, kind of defaults to single factor. Really not a good choice because obviously anybody could take their laptop at any time and turn off the network connectivity to make them offline and then basically gain access to username and password, be lazy, or it could be a nefarious user. So typically you're using either require offline MFA, where you enter an OTP code that comes from the mobile app, or it could come from a hard token that the user carries, or not allow, which is like, you got to use MFA no matter what. And we're not allowing offline. You're always connected. You should always be connected. We're not going to allow you to log in, authenticate any other way. And that is an important part in all of this is the ability to configure these independently for different users, because you will have people that require offline. There's no doubt about it. There's no way around it. But the base part of this will be is, what do you want most of your users to see? I think at this point, this is a pretty, good high-level overview. Only thing I'll also mention is that the application key ID and the application token that identifies your tenant in the MFA server also has the ability for you to define permissions. And those permissions ultimately decide how a user can authenticate. So you can lock down at the server level, what are these methods, passcode, call, phone, all the authentication methods that you specify here must also be allowed on the server. And there's some reasons for this. Obviously, you need to know some of this if you're doing offline. But the other real reason for this is that we can tailor the UI in a better way for the user by knowing these settings as they're specified here. We could dynamically get them from the server, but if somebody is offline or there's other things going on that might be difficult. So in this case, it's basically two different parts of the puzzle for security from the perspective of authenticating the individual and what methods they're allowed to authenticate. I would just like also say is that our push authentication, there's a lot of talk about, push authentication fatigue. I keep saying a nefarious individual logs in and keeps the individual that's associated with the account keeps getting dinged with waiting for you to log in. We're waiting for you to log in. The person keeps saying decline until they get completely fatigued and exhausted and just say, oh, okay, it's 2 in the morning. I want to go back to sleep, and say yes. We have our push authentication is smart enough to know that there's repeated requests, and you can configure it how long you want to let that go before you actually, disable the account because somebody's trying to compromise it, which is another important point to all of this. So this is WLM at a very high level, and thanks.